Hello, everyone. I would like to start by giving a warm welcome to everyone joining us today on our first session of the Arqus workshop series of AI in teaching and learning. First of all, a small introduction to why the series was born. It was born to gain insights into diverse teaching practices with AI from various universities and disciplines of the Alliance. Also to give a chance to colleagues to exchange ideas from all over Europe on the topic of AI in teaching, and also gain inspiration for the use of AI in your own teaching through good practice examples. As for some notes on how the session will go, please note that the presentations will be recorded and will be made available on the Arqus website and with slides and references. During the teacher's presentations, microphones will be off and participants are not allowed to ask questions related to the contents being presented, nor through microphone, nor in the chat. This will be possible afterwards during the breakout rooms. So save content-related questions to the Q&A sessions that will be following the speakers. For any operational technical questions, there will be someone in the Zoom call to help you with that. As for the breakout rooms, they will work after 4 speakers present their work. There will be 2 of them. A small note that you cannot change your breakout room after you choose it. So you will have 20 minutes of breakout room. You can choose which one you'll go to, then you can change to another one afterwards. This session will have 4 speakers. Each of them will have 10 minutes each, and they will talk about how AI has helped them in their teaching or for teaching support. That being said, it is with great pleasure that I start introducing our speakers. Our first one will be Elke Höfler from the University of Graz, she's an assistant professor for the educational technology and design language teaching at the University of Graz. Her research focuses on artificial intelligence, literature didactics, social media, and reading didactics, among other topics. She's also an educational blogger and co-founder of the educational network called EduPNX. So please, Elke.
Maybe we'll skip for another input first, please, because Elke is not here by the moment. I think she will be here soon. I try to contact her and reach her. Sorry for the delay.
No worries. In that case, we will begin with our second speaker, Professor Erin Missouri is an assistant professor at the physics at Durham University, working with practical uses of generative AI in higher education. She has designed course-aligned custom GPTs to support student learning using evidence from student evaluations, providing formative feedback on lab reports, and creating tutor-style GPTs that guide learners rather than give solutions. Her teaching foreground accessibility, inclusive practice, and active learning. Please, Professor Erin Missouri, you can share.
Thank you. Let's do this successfully. Bear with me. And does that look okay? Yeah?
Yes, thank you.
Okay, thank you. All right, so hi everyone. I'm Erin Missouri from Durham University. Also want to acknowledge the student who did a lot of the work in the evaluations of the tool and development, and Dr. Alex Peach, who's a colleague from the department. So I'm going to tell you about the genAI tool, and I want hopefully by the end of the 10 minutes we have is to have answers to these questions. So hopefully You'll see what the goal is and what the learning outcomes are for the module and the tool development, who is the target group. And then I'll share some details, not all of it because we only have a bit of time, but some details on how the tool works, how it was implemented and evaluated, and why we chose to use generative AI as a tool for this purpose. So that's for feedback on lab reports. The work has been published, so if you do want to read more details, the QR code is right there. Now, the aim of this tool is to provide timely, actionable feedback for students. And the module is a lab-based module, and students are expected to learn many different skills in this module. They need to learn how to write scientific lab reports formally, analyze and present data analysis, and also be able to present present the work in a setting, in a presentation. And students are expected to use feedback as well to improve on the work. And this is one place where what was highlighted in the surveys that we've done was that the feedback students have been receiving on lab reports hasn't been, well, it is detailed, but perhaps not as detailed or actionable as they want it to be. So here we're seeing from this bar chart here, that's a percentage of participants who selected different statements based on the Likert scale on the usefulness, length and timeliness and clarity of the feedback received from the markers on their lab reports. So what we're seeing is that the students, that a lot of them do appreciate, well, timeliness is one that has been positively highlighted here. There is definitely a need for an improvement on the actionability. So that's the usefulness. We did also do interviews, so we gained a lot more insights, detailed insights through that. So the usefulness, so that's actionability, clarity as well in terms of what it actually means. So it's making sense of the written feedback. And so this is what motivated this usage of generative AI. So focusing on the scientific writing style means it's an intervention that can support them in lab-based module, but also in other modules. Our students, the study and the tool was applied to first-year undergraduate students. So thinking about, again, the challenges faced by students. First years are the ones that have to face a lot of challenges, and one of them being starting university, but there's a lot going on and in a physics degree. So the early intervention here also guarantees that students learn how to use and apply feedback that can then benefit the rest of the degree. It's a pretty large cohort, an introductory module that covers a lot of different skills. So that's programming, data analysis, report writing, designing experiments and conducting experiments, and a lot of technical skills as well. So the challenges are from the for the module as applied to in terms of the feedback is the fact that there are a lot of students and there's a lot of markers as well, but we do have limited time and we do limit the feedback that we give. I mean, currently I was marking some work yesterday and we have a box and there's a certain character limit. So we do aim for the upper end of that character limit, but students do ask for more. And of course they want a lot more feedback. And what we found as well, because of the fact that there was a lot of different lab supervisors and academics who teach in the labs and mark the reports, there are inconsistencies. So some may give more detail, some may give less detail, and maybe the experienced academics may have some assumptions. Sometimes the more distant we are from the student experience or from when we were students ourselves. I guess we forget things that may not be clear to students. And so yes, this was one of the main challenges for us, which motivated this. But yeah, a lot more was revealed through the study itself. Now, the tool is based on OpenAI's GPT. So a GPT model was customized using custom GPTs, or what also known as these mini GPTs, using prompt engineering and a knowledge base. So the knowledge base included things like the lecture notes. So that's lectures on how to write a good report, what goes in each section. The knowledge base also contained the experimental scripts. It included the marking criteria, what good feedback looks like. So that's from pedagogy literature. And here is how the tool was then used. The student submitted their work. The human marked it, so it was marked by a person. That written feedback was then provided to students, so students would then reflect on that. The students' work was then passed through the generative AI tool, and the generative AI then provided strengths, weaknesses, and suggested improvement for each one of the sections of the lab reports, and then highlighted the weakest section in the report, and then provided a rewrite while applying the feedback that was generated. And then students. So the key thing here. So the key thing here is what we've seen in this diagram here is the need for the moderation. We are all very much aware of the inaccuracies generative AI can produce and the hallucinations. So it was very important for us to be able to review the output from the generative AI before students were able to see that. So this is where things were highlighted in red, for instance. So there are inaccuracies, and this is still in the development stages. And with time, these can be reduced, hopefully down to zero, once you get more and more data that you generate, that the generative AI can then learn from. So students can, another thing about using generative AI in this way is that students can ask follow-up questions as well. So again, even if the feedback from the generative AI isn't so clear, they can then ask follow-up feedback. So what this does, and again, the key thing here is it's about closing that feedback loop. So students often receive feedback from us and then look at the mark and then just go away and not even think about it. So the aim here is to create that more authentic experience as well, in terms of using feedback to then improve the report and apply, and actually maybe potential students could choose to rewrite and maybe not, but at least seeing a rewrite on how that feedback would be applied is useful. And this is more authentic in terms of the experience we have when we write scientific journal articles. So we decided to do this only for formative assessment, so no marks assigned. It was just about allowing students to see how actionable feedback can be applied and getting more clarity on the human feedback that they received. And we made sure also that the no data was retained by the genAI, so the memory was disabled for this. And so looking ahead, yes, we want to scale this, and so the study was done on not the whole cohort. It was selective, just because we wanted to make sure everything was okay. So the next stage is once inaccuracies are reduced close enough to zero, it's about scaling this. So students, why do we want to scale? Well, students loved it. These students did love it. They found the feedback valuable because it gave them clear steps on how they can improve the work. Compared to the human feedback, they thought it was a lot more detailed. Speed as well. It was received almost instantly. And the students appreciated the consistency and the comprehensiveness of the tool. So the next step is scaling this tool to reach the full cohort and beyond level 1 as well. So this isn't just about improving the feedback so that students are able to write better reports, though it was the aim. It's also about preparing the students for a world where they have to use AI and generative AI in the professional environments they'll be working in. So being able to evaluate the feedback and evaluate outputs from generative AI and think critically about it is an important skill that students do need to learn. And that is it for me for now. So hopefully I'll take questions when you do find me in the breakout room. Thank you for listening.
Thank you, Professor Missouri. It was a pleasure to hear your presentation. Now we will go back to Professor Elke Höfler, who is an assistant professor of educational technology and design and language teaching at the University of Graz. Her research focuses on artificial intelligence, literature didactics, social media, and reading didactics, among other topics. She's also an educational blogger and co-founder of the educational network called EduPNX. Please, Professor, you can go ahead.
Thank you very much. And sorry for my technical delays. Today is one of those days where nothing works, really nothing works. But I'm very pleased to talk a bit about one of my projects, one of my approaches. It's kind of behind the scenes of genAI. It's about language learning and how you can unmask the bias and hallucination, and maybe also AI slop in language education. So as for the other presentations, I want to start with the learning outcomes that are for the course in general, not only for that kind of part, this 2 units, that really specific units I want to show you, but then the implementation and the future perspective, just to have, yeah, it's after Christmas, but it's some wishes towards Christmas. So my future perspective is more what I want to have for future language learning and language teaching. So for my course, the learning outcomes were really clear because it was a course about AI. So it was a critical engagement with AI language output, because students really learn a language. They learn kind of, or they develop kind of an AI literacy. But it's really important to have those two combined. So to evaluate AI generated translations and feedback, not only if it's if the content is okay, but also if it's linguistically okay, if the register is fine, authentic, if it's authentic, and so on. Then, when it comes to the specific unit, it's to be aware of bias in general, of hallucinations and AI limitations, because I worked with images, and in images, you sometimes have more of those training data problems. So it's part of a multimodal literacy, where we have the AI part that is a surplus, or there that is added to the traditional multimodal competence. And as my group is a group of future language teachers, the third point was to how to integrate AI literacy, the awareness of bias, hallucination, and AI limitations into their teaching on a meta level. So the target group was a group of future language teachers. It's at the bachelor niveau. So the students are at a level between B2 and C1 when it comes to the European framework. And it was a course with 18 students, 2 male students and 16 female students, but that's kind of normal when it comes to language teachers at my department. So when it comes to the implementation, the first step was to have a stimulus. So students are shown a single complex image, and I mean a complex image. It was AI generated, and it was I have some examples here, but it was a street scene in that case. And the very important point is that the image should show really many things, people and objects and relationships, facial expressions, and so on, so that there is many things to see there and to work with. The second step was that the students had to do a description. So they were not allowed to use AI. They should do a description of the image. So we have the focus prompts, what is happening, who is involved, what do you infer beyond what you directly see, and what vocabulary gaps appear. So where do you need maybe vocabulary that you don't have? And that's really important because in this first they had to write a text in the target language, and were not allowed to use AI because it was their product. And it was the next step was then maybe you can guess the next step. So when now it's the students who do the description, it was AI to do the description, and we used ChatGPT, or we have our own GPT at university, and the AI chatbot did the same interpretation description, and we had the same focus prompts. So they used the same focus prompts they had when they did their interpretation. The next step was to compare the two descriptions. There were the points accuracy, hallucination, register style, cultural bias, and granularity. And just to have a bit of a spoiler, the DAI was really, really detailed when it came to interpretation. There were so many things that the students didn't even see, even after they had the interpretation, the DAI interpretation, they did not see those things. They could guess it was there. So they really looked at the language level and the cultural level and the description, and had to compare those two. And then we really discussed in group about bias, the blind spots, and we went a bit beyond because we thought of what was easy, were some things easy and some things hard for AI to describe. So it was kind of a bit of a cognitive playing with the students. In the next step, so it was not the last, but there's one more, but the sixth step was the revision and mediation. So they worked on their own descriptions once again. They added some vocabulary they gained from the AI description, some discourse markers, and they had to formulate in pairs, because they did the work in pairs, some guidelines for classroom mediation. So when should learners be skeptical, and when is AI useful for visual interpretation? And that was for the last step, because they had to do a paper afterwards, and was a meta-reflective paper where they wrote what they learned about language, what they learned about AI, and how they would explain these concepts to future learners. So we had this transfer to the teaching, to the future teaching as well. And when it now comes to my future perspectives, this course unit is really specific, so I don't see any more things to do with that. But for the language teaching in general, I hope that there will be more of a multimodal literacy that comes more central, or becomes central in language learning. A critical agency when it comes to being the human in the loop and to be responsible of AI output when we use it. Also, that the teacher's role is more guiding to an or leading to an epistemic awareness, and then responsible AI use, ethically and ecologically, because now we use it, but we don't really think too much of ecological consequences, ethical consequences. So the ethical question should be really at the center when we talk about AI, and I hope that we can do that in future a bit more and not just having the bias and the training data problems we talk about. Thank you for your attention, and if there are any questions, see you in the breakout rooms.
Thank you, Professor Elke. It was a pleasure to hear your presentation. Next, we will have Professor Alexander Gudula, who is the Professor of Empirical Communication and Media Research at the Leipzig University. His work covers AI in media, deepfakes, digital journalism, strategic communication, and international photojournalism. He publishes widely, co-edits a handbook on AI-driven media disruption, and co-leads a research project on the effects of deepfakes. Please, Professor Gudula, the stage is yours.
Okay, so thank you for your kind introduction. First of all, I hope that everyone can hear me. I don't see two skeptical faces, so I hope this is fine. I've been invited to talk about a very hands-on topic. I called it From Manuscript to Machine Partner, AI as a co-author in graduate scholarship. At Leipzig University, we have a master program which is called Strategic Communication, and we used to have the students create an own research project in a year. So this is a very big project, and many universities don't do something like that. And in the first term, they would create their own research project with real applied research on questions on strategic communication. And in the second term, they would create a scientific paper. And the scientific paper isn't only created in the course Research and Transformation of Communication in order to have them create a paper. Instead, we do really publish it. So the book you can see here is a real book. It is open source. I will give you a link in the end from our project so that you can have a look at it if you want. But I think that it is really important to have the students do an applied project which comes into the state of being quotable, being visible, and we can say that the students are very happy to do that. And we started with this during COVID. And AI was just a far-fetched story. No one was really talking about it in the way we do it now. So this was quite a great chance to add AI into this course in order to have a real long-term observation of how students use it. And since they have to create 6 articles, we will have a look at one of them as an example. It's really interesting because I was inspired by a talk from a colleague from Macromedia University who said, well, we changed something in the way students graduate. They are not only allowed to use AI in order to write a scientific report. Instead, it is mandatory. And I thought this is inspiring because the students have their own project, they have a report on their research, but what they don't have is a really good feeling for how good or bad is AI in everything. And so we try to implement the state-of-the-art tools of every year into this project. For example, as you can see, this book has a title, and we try to create different titles using AI, which is going on better and better with every year. Also, the cover is created via AI, and also the logo. So we do everything in order to experiment and to have an ongoing idea of how are the results. As I just told you, they are published in an open source way, and the students are very happy because they can quote their own work, and whenever someone else quotes their work, they are also very excited about this. We use the open access repository Sora Info, which works really well in my opinion. And when we go from there, these are just the infos that it is published as a Creative Commons thing. For example, we have this project which is published widely and can be accessed by everyone. This is the ongoing version which was published just a few months ago. And I would like to dive with you into one of the articles in order to discuss what happened in order to make this book happen using AI. So if we jump into just the first article, the editorial isn't that relevant for this because we tried to use AI in certain ways in order to, for example, write summaries. So this is something which is obviously working very well using AI. So if you have a finished paper and you want to summarize it and you're able to have an idea of whether or not it is correct what AI will do, I think this is a very good application. And the interesting thing is when you do a teaching project like that, the students obviously know their own project, so they can have an idea of whether or not artificial intelligence is actually helping them or not. So these are the 6 projects we conducted, and I will dive a little bit into the paper on right-wing populism in Germany because simply this is the first paper. I think they are all tremendous and splendid. But as you can see, it really is an application of how books are created. And again, for the writing of the abstract, which is the beginning of the paper, we experimented a lot with AI, and I would say this is something that works really well. This is also always a good test of whether or not the students are aware of the own paper they created. And again, for the introduction, they had their own introduction in the big report, which they created in the first term. But there, the students already told me that using artificial intelligence is nice in this way, but they are not so interested in applying strong AI like DeepL or Gemini or whatever, but instead they use a lot tools in weak AI like DeepL, which are very good in translating. And this is something which is even more worthwhile in this kind of content creation. And if we go through the paper, there are many sections, obviously. In the theory, we try to use tools like Quillbot in order to shorten content, which is also interesting and which leads to consistent results. But again, the really interesting thing is that students tell me, well, AI is helpful in creating all these sections and in order to shorten the content I already created. But in the end, it's a work that I have to conduct as an author. And this is, in my opinion, a very good teaching result that they have a good feeling of whether or not this is worthwhile what they are doing. And as you can see, we did everything you'd expect from a good scientific paper, like presenting our results and giving the reader a good idea of what came out of the project. And but still, I would say that if you go through a paper like that, how relevant was AI in order to create it? Not at all. But we can really see that the process is much smoother, much more efficient, and especially in the last section where this is where computers have always shined, for example, like checking references, making sure that everything is fit for APA, and so on. So this is where the students would always say this works really splendid on this level. We also do a conference every year. So this was the conference we did in the last year on the changes in communication. So all the papers are presented and they also create presentations, and we also experimented with AI in that sector. But I would say right now this isn't really that helpful because doing a presentation yourself is often much smoother and much more up to the task we have. Interestingly, they also created quotes we shared on LinkedIn in order to promote the conference. And again, it was obvious that even though AI can help you with this, the students came up with much smarter ideas right now than AI would do. So I was really happy about their capability to say something catchy about their own research. And so if you're interested in the book, You might download it right from SOAR because I think they really did a good job. And as a bottom line, AI was helpful, but I wouldn't say that it was a game changer for authorship in scientific communication and in creating own books out of student works. If you want to keep in touch, please drop me a line and use whichever form of contact which is useful for you. Thank you so much for your attention.
Thank you so much, Professor Kozula. And last but not least, we have Sebastian Passotti. Sebastian is a senior lecturer at chemistry education at the University of Graz. He is a chemist by training and started working on chemistry education in his postdoc. Currently, he has several research projects on the use of genAI in higher chemistry education settings. He does empirical research on students' use of genAI chatbots with a focus on how productive use of those chatbots can be achieved. Please, Sebastian, go ahead.
Thank you for the kind introduction, and I'm really happy that I don't have a German surname, but an Italian one, which really helps with pronunciation. But I don't speak Italian at all. I'm a Austrian potato in that regard. So for the next 10 minutes, I'm going to take you through what we do with our students in undergraduate organic chemistry. And since I think you might not have too much of an idea, or some of you at least might not have too much of an idea what organic chemistry or means at the university level, I'm going to try to take you through the whole course as I would take students through the course to make you understand how the students would work through the course. In terms of, wait a minute. Let me try again to share my screen. Somehow it doesn't want to go through the presentation. I'll retry opening and closing PowerPoint. Sorry. Okay. Now it works, at least for me. Okay, I'll talk you through the target group and setting first before talking about the learning outcomes and then implementation, and then switch into future perspectives. And in terms of target group, this was a joint research project between University of Graz and the Fordham University in New York City in the United States. For the implementation in Graz, we went with second semester bachelor students, and at Fordham University, they worked with sophomore students, which is basically second year university students. So it was between third and fourth semester in European terms, I would say. And what were the learning outcomes that we wanted to achieve? First, we wanted to talk about molecular representation and how molecular representation can also be made machine readable. Then about machine learning, and taking from machine learning, we tried to prompt genAI models to have maybe improved performance in terms of the chemistry outputs they give. So first, about molecular representation, I have to bother you with some formulas, but this is the language that chemists speak. So to say this would picture cyclohexene, which would be immediately recognizable to most chemists, but might not be to you in terms of interpreting this depiction. And molecular representation can come in different forms, depending on what you want to say. So it is not really useful or easy to depict all of the C and H atoms, for example. So we have some kinds of shortened visualizations for molecules. As here you can see, we basically omit the C's and basically say the double bond you can see on the right. So this is the same molecule, and we also omit the H's. Or if we want to look at the double bond in more detail, we can show the double bond and show molecular kind of geometry. What you can also tell from this is that while this might be a language that humans will understand well, there might be a problem for large language models to work with this. Usually they are good with text, but they are not so good with representations like that. So for that, there might be some formula or even IUPAC names. So you can see on the second line, cyclohexone would be a good password and the name of this compound. And yeah, with this representation form of an IUPAC name, the large language model can work much better, since the large language model, of course, is trained on language. Maybe not this kind of language, but on language. To convert molecular representations from one form to the other, there are several kinds of software. We use ChemDraw, and we had students use the molecular representations to work among them, and use ChemDraw to convert to the names. In this case, it looks pretty easy to convert the structure to the name, but it can get much more difficult to make all of that machine readable, and you will see why we did that in a few slides. So our first learning goal was to show students different types of molecular representations, have them convert between them, and choose fitting representations depending on the task. And now they will work with, or they worked with large language models. So they had to choose the text representation of molecules to work well in the context of the unit. In terms of machine learning, the learning outcomes were expected to have students understand that machine learning models can basically recognize pattern. And even if you don't know anything about chemistry at all, you can maybe tell that there is some kind of formation of a product going on here, where you see the double bond or double dash maybe, and there seems to be some kind of the same reaction going on. And while we as humans are really good at recognizing this in terms of pictures, I guess AI would be much better in recognizing this in terms of how does the product or the molecule name change, and can really work with this kind of pattern much better. And so students will come up with a set of reactions. So what they will do is work through a set of reactions and do the whole reaction over and over and over again in some kind of in this way. They have a molecule have some reaction, and they will get out a product, and then create a data set of educts and products, basically. So this compound will react with bromine to this compound and this compound, and they will put it in a machine learning data set shared among all of the students, and they will create a pretty big data set from this, or pretty big. I mean, it's 10 entries, but still a reasonable data set. And what is the idea behind that? We want students to know how machine learning kind of works, and why it is important to split training and test data. And we do this by having them generate training data and then work with that in what I will show you in the next slides. And for that, we have to look into into prompting of large language models. So a simple prompt would be something like, "What does a dog say?" And ChatGPT or any other kind of LLM would give you a pretty lengthy answer, and maybe generalize, have some bullet points or something like that, and give you some additional information. But if you ask, "What does a dog say?" you basically just want to hear "woof" or something like that, maybe. So you could use an in-context learning prompt. So you could say, "A cat says meow, a capybara says gra, a fox says yip. What does a dog say?" Then you could maybe get out some different kind of answer. So the doc might say ARF or something like that. So you give some kind of data how you want to present or how you think would a good solution look like, and then ask for a better solution. And the large language model will recognize patterns and give you in a better pattern a better solution. And basically you can just also use this for chemistry. So you can ask the students for this molecule, what might be a reaction product, and then they can use the reaction data set they created. So consider the reaction data set. Given these reactions, so the Excel file you saw before, what is the bromination product of 4-ethyl-3-methylhex-2-ane? And then the answer would be something like that. Again, a good password. I won't go through that. And then they can use this kind of representation and use software to get back to the molecule, and the answer will be much more likely correct. So to sum all of this up, students would receive bad answers from genAI if they just talk or just ask about what the reaction product of some kind of bromination would be. And if they use in-context learning prompts and give examples, they will get much better of an answer. This is especially important since the students will have to work for this data set and actually work through these kinds of reactions first to see, to create this data set, and then will get a better answer and have a use of genAI that kind of makes sense. So they will use, overall, they will use molecular representations, use a software that really can convert structures to names to get the names. And with pattern recognition, they will be able to get good outcomes. In terms of future perspectives, I'm currently working on designing GPTs that do all of this prompting in the background so that students get nice results with those GPTs as an entry or easy entry to genAI. And if you're interested in the paper, you can also now look into that. This is a shameless plug and self-promotion. Find it on ChemArXiv if you're interested. And with that, thank you for your attention, and I'm happy to answer any questions in the breakout session.
Thank you for that. Now we will go on to the breakout rooms. As I mentioned before, there will be 2 breakout sessions. You can choose one of the 4 rooms you wish to join. You can also change rooms during a breakout session, so be aware of that. After the first breakout room, you will be moved back to the general session, and then you can choose another session to go into. You can choose